Good day to the next video in our series on naming organic compounds as required for the CAPS document Physical Science Grade 12. In our first couple of videos, we addressed identifying a homologous series by its functional group. The homologous series that we were talking about were the alkanes, alkenes, alkynes, haloalkanes, alcohols, aldehydes, ketones, carboxylic acids, and esters. In our next video, we looked at the position of the functional group in a compound. In this video, we are going to look at identifying the number of carbons that is found in the main carbon chain. So, using our strategy from starting from the back of the name of the compound and working our way to the front, we have already identified the homologous series at the back, the position of the functional group, and now we are looking at the amount of carbons that is found in the main chain in our organic compound. These carbons are identified by specific prefixes. If I have one carbon in my chain, then I use the prefix me. Examples of this I'll find in methane, methanol, methanol, methanol. All of this tells me that there's only one carbon in the chain. If I have two carbons in my main chain, I use the prefix et. Examples include ethane, ethene, ethine, ethanol. By the way, if you look at these names, you should be able to identify quite a lot. You should be able to identify the homologous series to which all of these belong, and you should be able to name the functional group. And by now, from after this video, you should also know that these organic compounds have a longest chain that consists of, in this case, 2 carbons. 3 carbons use the prefix prop. Examples include propane, propene, propanol, etc. 4 carbons uses the prefix but. Butane, butane 1-ol. Aha! Where does this 1 come from? Remember, in our previous video, we looked at the position of the functional group. So let's see what information we gathered from this name already. Butane 1-ol, starting from the back, tells us that this belongs to the homologous series, the alcohols. The OH, which is the functional group of the alcohols, tells us it's sitting on the first carbon of the chain. The carbon consists of 4 carbons, or the carbon chain consists of 4 carbons, as indicated by this prefix. You should be able to identify the prefixes up to a chain of 8 carbons. That means you must know the prefixes of the first 8. 1 met, 2 et, 3 prop, 4 but, 5 pent, 6 hex, 7 hept, and 8 oct. In this video, there is an example of the different kind of compounds that you can find. Pent, which has 5 carbons. Examples of that will be pentan 2-ol or pentan 2-one for the alcohol or the ketone. Another example is for hex, where we use the 6 hexane. Let's see what information do we have from this name. Ending with ane, not having a halogen in front, tells us that this is an alkane. Because it's an alkane, we don't need to know the position of the functional group. We know that the chain consists of 6 carbons because it tells us 6. Hexanoate. Hexanoate anoate tells us we are dealing with a carboxylic acid. Carboxylic acid, the functional group, which is the double bond OH connected to the C, is at the end of the chain, so we don't have to indicate the position of the functional group. And then the amount of carbons in the main chain is 6 according to the hex. 5 is pent, 6 is hex, 7 hept, and 8 oct. Let's apply this to a few more examples. Let's apply all the knowledge we have up till now. In this first example, we start from the back and try to identify the homologous series to which this compound belongs. We see that we have an OH attached to the carbon. OH tells us that this is an alcohol. In this case, there is only one carbon, so there is no confusion of on which carbon the functional group is. If there is no confusion possible, then it is not necessary to indicate the number of the carbon on which the functional group is situated. I only have one carbon, which is an alcohol, so this compound has got the name methanol. Let's look at the second example. Start with a homologous series. The homologous series to which this one belongs is alkanes, because all single bonds and no halogens. I don't have to indicate the functional group for the alkane, and I see that I have 2 carbons in my main chain. So the functional group for this one, or the name rather, for this one would be ethane. My next example. In this entire compound, I have a double bond. So I know the homologous series for this compound is the alkenes. Now I have to identify the position on which the double bond is. 1, 2, 3. I can number all 1, 2, 3. In this case, I can see if I number from this side, the double bond is after the first one. And this is the only way that I can number. So in actual fact, it is quite frankly impossible to have prop 2-ene. The only way in which propene can be written is with a double bond on the first chain. Why do I say this? Because as soon as I place the double bond over here, it will just mean that I start numbering from that side. Therefore, the position of the functional group in this case is not as important to indicate. But what is important to indicate is the amount of carbons that is present in the current chain. I've got 3 carbons, so therefore I will use the prefix prop, and hence the name propene. Let's look at the next example. To which homologous series does this example belong? I can see it's to the haloalkenes. Okay, haloalkanes, because there's a halogen attached to the alkane. So I know that this one will end in ane. But with the haloalkanes, there's a slight problem or a slight exception to the rule. The position of the halogen is not indicated at the back of the name, but the front. And we will handle this in the next video. So sorry for creeping in this example, just to show you that things aren't always in exact ways done. So what do we know? It's going to end with an ane. We're going to have somewhere indicate where the chlorine is. And in this case, we'll probably number from this side. 1, 2, 3, 4. And we know that in our main chain, we have 4 carbons. Therefore, we know that this will include a butane. Let's see, how did we do? 1-chlorobutane, not bad. We have not really looked at exactly how we should include the halogens, and we'll look at that in the next video. But by now we were able to identify that this is part of an alkane or a haloalkane, and we were able to identify that the main carbon chain consists of 4 carbons. Another example. Now what do we have here? Functional group. If I identify that, I've got my double bond O, which is situated on a carbon in the middle of the chain, telling me that this must be a ketone. Because it's a ketone, the functional group can have more than one position. So I have to go and number my main chain. Can you see if I number it from this side? Then the ketone or the double bond O will be on the second carbon. So I know this compound will end with the name 2-one. And then the prefix to that, how many carbons are in the main chain? 1, 2, 3, 4, 5. So this will be penta-2-one. The next example, let's see if you can figure out this name on your own. Were you able to do this? Functional group at the end of the chain. tells me that this is an aldehyde and must end in L. Because it's an aldehyde, there's no need to identify the position of the functional group. So all that remains is to count the amount of carbons, 1, 2, 3, 4, 5, 6, and see that the name of this compound is hexanol. Our last example in this case, a carboxylic acid at the end, showing us that this will end in anoic acid, again a functional group that we do not have to indicate, consisting of 7 carbons, telling us that this is going to be heptanoic acid. Now see if you can identify some names in the following revision exercise. Good luck!